Hello everyone and welcome back to my YouTube channel or the Vig Structure Hub. So today I want to tackle example number 1 under rectangular dams. The question is on the board and it reads: a masonry dam of rectangular section 20 meters high and 10 meters wide has a water up to a height of 16 meters on its one side. Find Roman 1 the pressure force due to water on 1 meter length of the dam. Roman 2 position of center of pressure. Roman 3 the point at which the resultant cuts the base. Then take the weight of masonry as 19.62 kilonewton per meter cubic and weight of water equals to 9.81 kilonewton per meter cubic. So let's see how you can handle such a question. Solution. So the first approach is to draw the dam. So I will draw the dam here. So that is the dam. It is 20 meters high. So this is 20 meters and 10 meters wide. And then the height of the water is 16 meters on its one side. So let's assume this is the height of the water. So the height is 16 meters, like that. So this water, so this is water and this is dam. It is made up of masonry. So this water is exerting pressure on this dam. So this is our force. So if we can prolong this force up to the other side, again, the dam itself, it has a pressure, a weight, which is W, exerting here, and then we have our resultant force, so we call it R, and then you can prolong this line and this, so this distance you can call it X, and the center of pressure is H over 3, like that. Roman 1 position of center, no, the pressure force due to water on 1 meter length. So Roman 1 pressure force. So how are you going to calculate the pressure force? So this F is the pressure force of water on the side, on one side of the dam. So we know that F is equal to W times area times H bar. This is the formula from our previous analysis. But if you can find problem in getting this formula, you can use the basic, whereby you know that density is equals to mass over volume. So this mass, you can convert it to force by multiplying 9.81. So instead of using mass, you can use force. So therefore, making force the subject of the formula will be density times volume. Then you go further ahead, density times area times h. And remember, h is the center of h for this case. By doing so, you have already generated your formula. So this density, you can convert it to weight. So weight times area times h bar, like that. So our force is weight times area times h bar. And remember, our weight here is the weight of water. At times, you may not given this weight of water as 9.81 kilonewton per meter cubic. But we know that the density of water is equal to 1,000 kilogram per meter cubic. So this is standard, you should know this. So from this, you can say that the weight of water, you convert this first to Newton, which is 9.81 times 1,000. This now will be Newton per meter cubic. So this 9.81 is the gravitational acceleration. So you will get 9810 Newton per meter cubic. Then you multiply by 10 to power negative 3. So you will get 9.81 kilonewton per meter cubic. So that is the unit weight of water from density of water, which is 1,000 kilogram per meter cubic. So at times, if you are not given this 9.81 kilonewton per meter cubic, know how you can get this 9.81 from density of water, which is 1,000 kilogram per meter cubic. So in our case, we have already been given. So our force will be the unit weight of water is 9.81 times 10 to power 3. I'm converting from kilonewton per meter cubic to Newton per meter cubic times area. So area for our case here will be 16 times. You have been told pressure force due to water on meter length of the dam. So meter length times 1 meter, then times h bar is 16 over 2. So if you punch your calculator, you will get the answer. So our force is 1.25 68 times 10 raised to power 6 Newton. So you can leave your answer in Newton, or you can convert it to kilonewton again by multiplying. So in kilonewton, it will be 1.25568 times 10 raised to power 6 times 10 negative 3. So times 10 to power negative 3. So the answer will be 1255.68 kilonewton. So that is the answer for Roman 1. We proceed to Roman 2. Roman 2, position of the center of pressure. So we know that if we can draw a pressure diagram, we will have a triangle, a right angle triangle like this one. So that is a pressure diagram. So this is the pressure acting on the wall. And our force here is at this point. So, and from the base, no, the height of this pressure is 16. So we are supposed to get the so this is H over 3. So the position of center of pressure will be, so position of center of pressure is equal to 16 over 3. So which imply position of center of pressure is equal to 16 divided by 3. So that is 5.33 meter from the base. So from the base here. So H over 3 is 5.33 meters. You are done with Roman number 2, Roman 2. We proceed to Roman 3. So Roman 3, point at which resultant cut the base. Resultant cut the base. Point. So this is our resultant, which is R. So what you are looking for is this distance x from here to here, so that we can know where this resultant x is cutting at this point. So this one, you can use the formula in our previous, the formula that we derived in our previous analysis of rectangular dams, or we can sum moment at this point F. So the easiest way is sum moment at this point F, so that you may not cram the formula. So let's say summation of moment at, let's call this point N. This point N. So this is N. So summation of moment at N is equal to 0. So if you sum moment at this point N, we'll have this W as the weight of the dam moving in anti-clockwise direction, as you can see. So we'll have negative W times the perpendicular distance x times x. Then we come to this force F. This F is moving in this direction. So this direction is clockwise. Plus F times the perpendicular distance is this h over 3 from here to here, times h over 3 is equal to 0. So our W is the weight of the masonry, and we have been told the weight of masonry is 16.62 kilonewton. So to get this W is not the weight, it's the mass of the masonry dam. So you will say, but W is equal to 19.62, which is the weight of masonry, 19.62 times 10 raised power 3. We are changing from kilonewton to newton, then times the area. Area is 10 times 20. So this is the area, 10 times 20. Then times height. Height is 1 meter, because we have been told to use 1 meter length of the dam. So times 1. So this one will be So this one is 3.924 times 10 raised power 6 Newton. Then to get x, we'll use this expression. So we'll have negative 3.924 times 10 raised power 6 times our norm x plus f. Our f here is 1.22556 times 10 raised power 6. I'm using this because this is in Newton, and also this is in Newton, times h over 3 times 5.33. So our h over 5 is 5.33. So should we give you 0, which imply x is equal to, you will express this or simplify mathematically to find the value of x. So it means this expression will cross to the other side, so it will be positive. Then this will remain on this side. So to find x, we'll divide both sides by 3.924 times 10 raised power 6. So our x will be 1.25568 times 10 raised power 6 times 5.33, and then you divide by 3.924 times 10 raised power 6, which imply x is equal to, then you punch your calculator. So which imply x is equal to 1.706 meters. So that is where the resultant force cut. So that is the end of that question. Also, you can use another method to find this distance x. You can use the formula we derived in our previous lesson. That was analysis of a rectangular dam. So this is the formula. So X is equal to FW times H over 3, and our W is the force of this dam. So which will be the weight of the masonry wall, which is 19.62, converted to Newton times 10 raised to power 3. We are converting from kilonewton to Newton, times the area. Area is 10 times 20 times the length of the dam. We have been told to use a 1 meter length of the dam, so times 1. So here you will get 19.62 times 10 to power 3 times 10 times 20 times 1. So the answer is 3.924 times 10 raised to power 6 Newton. So X is equal to, our force is this pressure force, which is 1.25568 times 10 raised to power 6 Newton. So I will use this because it is in Newton, and also this one is in Newton. So 1.25568 times 10 raised to power 6 over 3.924 times 10 times 10 power 6, and then times h over 3, 16 over 3, which imply x is equal to, so x is equal to, then you punch your calculator to get x. So the answer still remains the same, 1.707 meters. So that marks the end of that question. Example number 2, the question is on the board, and I will read the question. A masonry dam of rectangular cross-section 10 meters high and 5 meters wide has water up to the top on its one side. If the weight density of masonry is 21.582 kilonewton per meter cubic, find Roman 1, pressure force due to water per meter length of the dam. Then Roman 2, resultant force and at the point at which it cuts the base of the dam. So solution. The first thing to do, or the first approach, is to sketch the dam. So we have been told this dam it is at the same height with water. So here is 5 meters wide. So this is 5 meters. This is dam, and this is water. And then 10 meters high. So the height of water is the same as the height of dam. This is 10 meters high water. So the water up to 5 meters wide has water up to the top on its one side. If the density of masonry is 21.582 kilonewton, find pressure force due to water. So this is the water. You can assume the pressure force is acting at this point. So this is F. And this will be the center of pressure, which will be H over 3. So we'll proceed, we'll extend this to the other side, force, and then the dam again, it has a force W acting on it, and then we will have the resultant force, which is R. So we'll extend here and also extend here, such that we'll have our distance x, where our resultant force is cutting. So let's start calculating Roman 1, pressure force due to water per meter length. So Roman 1, pressure force. So to calculate a pressure force, you need the density weight of water. For this case, we have not been given, and I told you if you have not been given, you can calculate from the standard density of water, which is 1,000 kilogram per meter cubic. So we know that the unit weight of water is equal to 9.81 kilonewton per meter cubic. This one should be on your fingertips. It is something that you should know always. And the density of water is 1,000 kilogram per meter cubic. These two should be on your fingertips. But for our case, we will use the unit weight and not the density. So you can also generate the unit weight from this density. So the unit weight of water is 9.81 kilonewton per meter cubic. So you know that force, which is F. So F is equal to unit weight of water times area times H bar. So our unit weight is 9.81 times 10 raised to power 3. I'm converting from kilonewton per meter cubic to Newton per meter cubic times area. The area of the dam will be this distance 10 times 1, because we have been told to calculate per meter length of the dam, so times 1. Then H bar is 10 over 2. Then you punch your calculator to find the force, which is F. The answer is 490, 500 Newton. We are done with pressure force. We proceed to Roman 2, the resultant force and the point at which it cuts the base of the dam. So Roman 2, resultant force. So the resultant force is this R. So if you can use the Pythagoras theorem, so this is the resultant force, and this is W, and this one is F. So from here to here is F. So to get R will be the square root of W square plus F square. So our W, let's use W0. This one will be the force of this dam. So it will be, or the mass of this dam. So it will be the density of the dam, the density, the weight density of masonry, which is 21.582 times area times length. So this one will be 21.582. The area is 5 times 10 times length 1 meter. Use meter length of the dam. So the answer will be 21.58 times 5 times 10. So the answer is 1079 kilonewton times 10 raised power 3. We change from kilonewton to newton, times 10 power 3. It will be 1.079 times 10 raised power 6 Newton. So R is equal to the square root of 1.079 times 10 square plus F, which is 4.905 times 10. So R is equal to the square root of 1.079 times 10 to power 6 square plus 490 500 square, which imply R is equal to, again you punch your calculator. So the answer is 1.1853 times 10 raised power 6 Newton. So that is our R. Then we proceed to where it cuts the base of the dam. So we are proceeding to X. We know that X is equal to FW times H over 3, which is equal to, our F is 490, 500 over W. W is 1.079 times 10 to the power 6 times H over 3, 10 over 3, which imply X is equal to 1.51 meters. So that is the end of that question.